Okay, hi guys. Sorry I can't be there with you today, or maybe I am there and I'm just letting you listen to this anyways because I've already taken the time to do this. But anyways, we're writing exponential equations today. You've actually had a little bit of experience with this, so hopefully it's not too terrible and it's just bringing back things you already know. But before we jump into writing some equations, it's important for us to make sure that we understand some words that we're going to see in there, such as double, triple, half, quarter. Others, there could be quadruple. So what do these words mean? If we're doubling something, it means we're multiplying it by 2. And these are all multiply words. To triple it would be to multiply it by 3. Half of it, yes, would be to divide by 2, but we're going to think of it as multiplying by a half. To quarter something, just think of what you have in school. You spend 4 quarters in a school year. That is going to be divided into 4. So we're going to multiply by a fourth. Our exponential equation formula should not be unfamiliar to you. You've got your a and your b, and of course we recognize it's exponential because our variable is an exponent. A represents our initial quantity. How much are we starting with? And b represents our growth or decay factor. Part of your job today is going to be to be able to determine whether or not we are growth or decay from the information given to you in the problem. Remember growth, all of our b values should be greater than 0. And our decay factor means that we are between 0 and 1, but we cannot be negative. Be careful of fractions that happen to be improper fractions, but I don't think we should have any of those to deal with in these word problems. All right, so given a word problem, first thing we're going to do is figure out whether we're exponential growth or decay. We'll fill in the information that we need in order to write our equation. We'll write our equation, and then we'll use that equation to get an answer to the question. So we've got a soccer tournament. Half, there's one of those keywords, of each of the teams are eliminated after each round. If there were 64 teams in the beginning, how many of the teams are there after 3 rounds? So the half and the eliminated should indicate to you that this is a decay problem. Initial amount, we started out with 64 teams. How fast are these teams being eliminated? Well, half. There's our decay factor. And that piece of information should match. So if you say this is a decay problem, then your decay factor better be a number that is smaller than 1. So therefore our equation is just f of x equals 64, 1/2 to the power of x. It is important to note that x represents the number of rounds. So the question asks, how many teams are there after 3 rounds? This is going to be our x value. So we're going to use this equation to actually calculate how many teams would be left. So over here in this space, so f of x is going to equal to that 64, 1/2 of x. We're going to replace the x with 3 because that's the piece of information I'm looking for. So let's remember our graphing calculators if we are going to be using them, which we should be, that we are going to use the up arrow key, which is right above the division sign, to represent an exponent and to get an exponent. So given my graphing calculator, I'm going to put it in exactly as I see it on my paper. Up arrow, which is right here above that division key. And notice on this particular calculator it actually looks like an exponent. I like to go with the rule, let's put it in parentheses, any exponent. Notice I have a little arrow up here pointing to the right. So I'm going to go to my arrow key pointing to the right, and it brings me back down. And I hit enter, and I see I would have 8 teams left. Now I realize some of you do not have that function on your calculator. So I'm going to do it on a different calculator so that everybody sees the same thing. So if I was putting this calculator or this one in, the 64 1/2, but this time when I press the up arrow key, again, which is right here, you see the up arrow and it does not look like an exponent. This is why we have to put parentheses around our exponent so that we make sure our calculator knows exactly what we want it to do. hit enter, and we still get the exact same answer. So it does not matter which calculator you have, you just have to know how to use it. So regardless, after 3 rounds, we have 8 teams left. All right, the next 2 are very similar to this, so if you feel pretty comfortable with them, I'd say skip the video, try the problems, and then just come back to make sure that your answers are correct. If you want to listen to me go through the next couple of examples, feel free to do so. And again, if you're ready to move on, move on. All right, number 2, zombies are taking over the world. Each minute, the zombie population is doubling. There's our clue word. We started with 3 zombies. How many zombies will there be after 10 minutes? Well, if the population is doubling, this is definitely a growth problem. I started out with 3 zombies. Growth factor, double. So my equation, f of x, 3 times 2 to the power of x. And always important to note what x is representing. And since we're doubling each minute, this is the number of minutes. The question wants to know how many zombies are there going to be after 10 minutes. So I'm going to take my equation, and I'm going to replace my x value, since x is number of minutes, I'm going to replace it with 10. So now back to my calculator. 3 parentheses 2, up arrow, 10. This one the right arrow. Hit enter. I've got myself a buttload of zombies. 3,072. So after 10 minutes, we've got 3,072 zombies that we now have to deal with. All right, same idea here. Number 3 actually kind of represents my yard. So the number of dandelions growing in your yard triples every day. Triples is our clue word. If your lawn started out with 15 dandelions, how many would you have in it after 2 weeks? Ooh, I like this question. Well, the triples, first of all, indicates that this should be growth. Initially, I started out with 15 dandelions. Since I'm growing, my growth factor is 3. So my equation will be f of x, 15, 3 to the x. Now, this goes back to why this is important to identify what x is representing. Go back to my question. The number of dandelions is growing in your yard triples every day. This represents the number of days. So when I go to answer this question, how many will I have in 2 weeks? My units don't match. I'm talking about days, this is talking about weeks. So we have to be aware of that piece of information so that we can translate it. That there are 7 days in a week, so therefore 2 weeks is the same as 14 days. So be mindful of what this is representing and what you're being asked, because you might have to translate that. So how many will I have after 2 weeks? Probably a lot of dandelions. So here's my equation. So again, this is representing number of days. So do not put in a 2. We're going to put in 14. I'll use the older calculator version on this one. So 15 times 3 raised to the power of, keep my parentheses around my exponent. And wow, I don't even have grass anymore. I just have dandelions. 717444535. That's 71 million dandelions. I'm glad they really do not reproduce that way, or else I really would not have a yard. All right, so one's on the back. Same idea, just a little bit of a different formula for you. So let's take a look at those ones.